Okay, so today we'll start out by finishing up section A4. Okay, so that's the section in the back. We did adding and subtracting yesterday. Today we're going to look at multiplying and dividing. Okay, as I said, the way I'm going to show you how to multiply and divide today works fine if you're going to write your numbers like this. Well, there's a better way to write these numbers. Okay? And that's where we're going to start to see the connection between what we did in polar and what we're doing now in complex numbers. Right? That better way of writing them makes multiplying and dividing very easy. But we don't know the better way of writing them yet. All right? So we're going to stick with the way we know for now, which is real part plus or minus imaginary part. And we'll learn how to do it this way. And then towards the end of class, I'm going to show you how to write these the better way, but we're not going to learn the shortcut for multiplying and dividing until tomorrow. Okay, so we'll start to learn what we need to use to do the shortcut, and we'll finish it up tomorrow. All right. So yesterday we said I equals the square root of -1. Why? Because it does. Because that's the way it is. It's the way it was meant to be. All right, I equals the square root of -1. It's like asking me why lines that are parallel don't cross, because they don't. It's the definition. So that's just what we define it. Now, as long as we all agree on that, this we actually went through and proved. What number was I squared equal to? -1. So I squared, and I proved that yesterday, equals -1. So that means anytime you have an answer, if you leave I squared in the final answer, I'm automatically marking it wrong. Because I squared is not simplified. You always change I squareds to -1s. Okay? So I am warning you, there will be multiple choice questions on the test, and it'll have I squared as one of the choices. If you pick it, are you going to be right or wrong? You're going to be wrong. But people always pick it. So do whatever you want. But I'm just telling you, you need to simplify I squared to -1. And I'm writing it out for those that are not as auditory. You're more visual. There you go. There's a visual. Okay. Any questions on that? All right. So let's look at how we multiply complex numbers. Multiplying is really the most important thing today, because when you do division, you really use multiplication. So if multiplication doesn't make sense, then nothing's really going to make sense today. So you're going to have two complex numbers, okay? Kind of like that. In a real problem, it'll look like that. You'll have actual numbers. Okay? But here's your A is your real part, B is your imaginary part. That's your first number. C is your real part, D is your imaginary part. That's your second number. So to multiply them together, we basically do that. Does anybody remember what that's called? All those lines? FOIL. You multiply the first terms together. That's the A and the C. Then you multiply the outer. That's the A and the D. Then the inner, the B and the C. And then the last, the B and the D. Okay? So that's how we multiply it out. Some people don't learn FOIL. Some teachers don't like to explain it that way. So if you've heard like a teacher say it's the distributive property twice, that's what you're doing. Distribute A to everything, distribute the BI to everything. All right. So when we do that, especially this last part, something with an I times something with an I. Well, that's going to give you something with an I squared. Okay, so I squared is going to come up when you multiply the last terms together. Okay, and we need to take care of that when it comes up. Okay, so let's multiply these two complex numbers together. When you're done, you should have an answer like this. Real part should be right there. Could be a plus or it could be a minus, depends on the problem. And then you should have an imaginary part right there and an I right next to it. That's what your final answer should look like. Real part, it'll be plus or minus. I don't know which one, we'll see. Imaginary number, and then an I. So let's do it out. Okay. What would be first two things I multiplied together here?
2 and 1.
Yep, 2 times 1, and that's going to give me 2. Next two things? 2 times negative I. All right, so we're distributing the 2 to everything. So we distribute it to the 1, we distribute it to the negative I. Now, when you multiply it, we know I is not a letter. Okay? In the English alphabet it is, but I stands for the square root of negative 1. But if you think of it as a letter, it follows all the same rules. So if you know what 2 times negative x would be, then you should know what 2 times negative I would be. It's the same idea. Right? So what's 2 times negative I going to come out to?
Negative 2i.
Yep. Now we have the inner, 1 times I. What's 1 times I going to give me? I. If you wanted to put 1i, you could. You can just write I, that's fine. And now the last term, positive I times negative I. Okay. Start with this. Positive times negative. Negative. I times I is what? I squared. Okay. So now, if that was a choice on the test and you pick it, that's not right. You're not done. You have some like terms to combine, and we got to deal with that I squared. What's negative 2i plus I?
Negative I.
Negative I. Or negative 1i. Yep. Minus. Now I just copied the minus down. What is I squared?
Negative 1.
Negative 1. Yes. So now I have 2 minus I minus minus 1. Well, what's minus minus 1? Plus. I'm really writing out every step. You could probably do some of that in your head, but I'm just showing you every single step the first time. Now we have 2 more like terms we can combine. We have a 2 and a 1. If you combine a 2 and a 1, what's that going to mean? 3 minus I. There's your answer. 3 minus I. So does that fit into the template I had right here? Yeah. 3 minus, technically it's 1i. 3 minus 1i. That's how your answer should always look.
Wait, that's the only way that all these answers can come out?
Yes, they should always have real part, plus or minus, and then an imaginary part.
That's it.
Yep. I mean, the numbers will be different in every problem. It could be 6 minus 5i or 8 plus 2i, but you're always going to have real part, plus or minus, and then a number with I. Yep. So if you leave it like this, wrong. You didn't finish it. If you leave it like this, well, that's better because you changed I squared to negative 1, but it's still wrong. You didn't finish it. Same thing here. If you leave it like that, no, you didn't combine like terms. So you gotta finish it. Okay. Questions on that one? Okay. Let's look at one more of those. So 8 plus I times 3 plus I. Okay. Jasmine, what would be the first two things I would multiply together here?
8 and 3.
8 and 3. And Jose, if I multiply 8 and 3, how much would that give me?
24.
Yep. So I get 24. Maddie, the next two things?
8i. Oh, 8 and...
Yep. So 8 and I, and she already did it. 8 times I, there's your 8i. Kyle, the next two things I multiply?
I times 3.
I times 3. And if I multiply I times 3, Caitlin, what's that going to be? 3i. Now some people just combine them as they go. They just write 11i, and that's it. And then I times I is going to be what? Positive I times positive I.
I squared.
Positive I squared. And again, if I was doing this, I probably would have changed that as I went to negative 1. Okay, so now we have 24. 8i and 3i gives me
11i.
11i. Especially when I have 1s and i's next to each other, I really try to make them look different. So 11i plus I squared is really what?
Oh, -1.
-1. Yep. So last step, 24 minus 1.
23.
23. And my imaginary part? 11i. Okay. And that's it. Any questions on that? Now, we jumped right into the most complicated distributive property. I didn't even do one like this. But if you had to do a problem like that, that's simpler. All you have to do is this. 8 plus 10i. That's not FOIL because it's only one thing on the outside. It's not two sets of parentheses next to each other. So any question on that? 2 times 4, 2 times 5? That's actually simpler. Okay. But on the test, you're probably going to see one, you're definitely going to see one where you have to FOIL. Okay. Now, don't get confused with the ones we did yesterday. Sometimes on a problem like this, people will write this as the answer. They write that. If somebody wrote this as the answer to this problem, example 2, what did they do? They added it. There's no addition sign there. If I put an addition sign in there, then yeah, that's the answer. 8 plus 3 is 11. I plus I is 2i. But when there's no addition sign, that's not addition at all. That's multiplication. So you got to FOIL. Okay, so don't make that mistake. Okay, just look at the problem. If you see addition, do addition. If you don't, and it's like this, you're doing multiplication. Yep.
Why are we learning this with polar coordinates? Like, I don't know, it just seems like two different things.
You're going to see the connection.
Okay.
You're going to start to see it today, and then tomorrow you're really going to see the advantage of the connection.
Okay.
So, that's what's coming up next. All right. So, there we go. Okay, so suppose we have a complex number. I'm just going to name the complex number. I'm going to call it Z. This complex number has a real part and an imaginary part. The real part is A, the imaginary part is B. You can call the real and imaginary part whatever you want. A and B, C and D, X and Y. It doesn't matter. It has a real part and it has an imaginary part. Well, if you put a bar above that letter, okay, so if you got a complex number Z and you put a bar above it, that means the conjugate. Okay, so this symbol means the conjugate of your complex number. Now, does anybody know what that means? What the word conjugate means? Not like conjugate a verb in like Spanish or something, but it's a little different. Anyone know what conjugate means? All right. So, the conjugate basically means if you started with A plus BI, you change it to A minus BI. So all it means to do when you have the conjugate is change the sign that's right there. If it was a plus, it becomes a minus. If it already was a minus, it becomes a plus. So you change the sign of the imaginary part. And the word that means change the sign is negate. Negate means do the opposite. So like if I said, everything I tell him to do, he just negates me. That means everything I tell you to do, you're just doing the opposite of what I say. You're not listening. So negate means change the sign of the imaginary part. Make it the opposite. You don't do anything to the real part. And the reason I'm showing you what a conjugate is because when we do division next, you need to know what a conjugate is. Okay, so now I'm just going to put up a chart, and we're just going to practice with a number and then finding the conjugate. Okay, so on the left is a complex number I'm calling Z. That's just the name of it. So in this case, Z is 3 plus 4i. I want to know the conjugate. So based on what I just said, what would be the conjugate of 3 plus 4i?
3 minus 4.
Yep. 3 minus 4i. That's it. That's the conjugate. Finding the conjugate is pretty simple. And on the test, I'm not going to ask you to find the conjugate of something. You're going to have to do that when you do division. That's where it's going to come up. How about this one? -8 minus 2i. What's the conjugate? -8 plus 2i. Yep. All right. How about 5i? What would be the conjugate of 5i?
-5i.
-5i. If you're like, well, that one looks a little different. Well, think of it this way. It's 0 plus 5i. There is no real part. So what's the conjugate? 0 minus 5i. That's all. How about 3?
Is it just 3?
3. So think of it like this. 3 plus no imaginary part. The conjugate is 3 minus no imaginary part. Does it make a difference if you do plus 0 or minus 0? Nope. So the conjugate of 3 is 3. You don't change the real part, just the imaginary. So any questions on how to find a conjugate? Okay, so now let's take a look at this. I want to multiply a complex number times its conjugate and see what happens. So I'm going to give you a complex number and I'm going to ask you to multiply by the conjugate. There's your complex number, 3 minus 4i. So I want to take 3 minus 4i, and what do I want to multiply it by? Yep.
The conjugate of z.
Which would be
3 plus 4i.
Yes. I want to do that out and see what I get. Now, I already know the answer is 25. Not because I've done this problem before, but because I actually just did the whole problem in my head. And I didn't FOIL. We're going to FOIL. But you're going to see you don't need to FOIL. There is a shortcut to multiply these together. Okay, watch what happens. So start with the first. Okay, and remember, 25. That's what I told you the answer is going to be. Okay. 3 times 3 gives me how much? 9. How about 3 times 4i? 12i. And what about 3 times negative 4i?
Negative 12i.
Negative 12i. Well, that was a waste of time. We did positive 12i, negative 12i. Those are just going to disappear. And anytime you multiply conjugates together, that's going to happen every time. So if it's just going to disappear, I'm not going to bother doing it. So first, that's good to do. Outer, inner, you don't need to do it. But you do need to do the last. Negative times positive gives me what? Negative. And then 4 times 4? 16. And don't forget about the I times I. I squared. So I get 9 minus 16 times I squared. What's I squared? Negative 1. What's negative, or what's 16 times negative 1?
Negative 16.
Negative 16. So I have 9 minus, and I just got negative 16. What's 9 minus minus 16? 25. Right? It's like 9 plus 16. And that's what I told you the answer would be. So, how did I do that without actually foiling it all out? Look at any one of these complex numbers. Doesn't matter which one. Let's look at the first one. What's the real part in the first one?
3.
3. Square it. What's the real part in the second one? Just the number... what?
3.
Oh, I'm sorry, you're right. 3. What's the imaginary part? 4. It doesn't matter. 4, negative 4, it doesn't matter which one you use. So let's use the negative 4. Square it. So square the real part, square the imaginary part, and add them up. What's 3 squared? 9. What's negative 4 squared? 16. That's exactly what I got by foiling it. So all you have to do is square the real part, square the number in front of I, and add them up. That's a shortcut. If you don't want to do that shortcut, don't do it. You don't have to. But it saves a little bit of time. All right, so let's look at this one. Doesn't matter which number you look at. What's the real part of the first one? 5. Square it. What do you get?
25.
What's the imaginary part? 4. Square it. What do you get? 16. What's 25 plus 16?
41.
41. Yep. So if you were to FOIL all that out, that's what you would get. Now, look at the kind of answer you got. 41. Look at the kind of answer we got up here. 25. What kind of numbers are those? 41, 25. Thinking about the kind of numbers we're studying right now.
Real number?
Those are real numbers. So the point when you multiply conjugates together is all the i's disappear. That's the point. You make all the i's cancel out. That's why you multiply by the conjugate. Right. So I wrote down the pattern for the shortcut if you want to use it. If you want to multiply a number by its conjugate, remember, A is the real part, B is the imaginary part. Take the real part and square it. Take the imaginary part, square it, and then add them up. That's exactly what we just did right here. 5 squared plus 4 squared. And if you're thinking, well, wait, isn't it negative 4 squared? It doesn't matter. If you square a negative, it becomes a positive. Okay. If that's confusing, don't do it. Just FOIL it all out from scratch every time. And you're going to waste some time because some stuff is going to cancel. But if you just want to do FOIL and not use the shortcut, that's fine. But I'm going to use the shortcut. Okay, so now we're ready to look at the last thing, which is how do we divide two complex numbers? Well, you're going to have to use the conjugate. So, to divide two complex numbers, you actually multiply. Okay, you don't divide. So to divide two complex numbers, you're going to multiply the top and the bottom of your complex number by the conjugate of what was in the bottom. So a problem would look like that. Now, the problem with example 5 is you are not allowed to leave I in the denominator. Just like you can't leave square roots in the denominator, you can't leave I in the denominator. So, we got to get rid of all the i's somehow. We just learned how to do something that automatically cancels out all the i's. That's why we're going to use it. Okay. So directions say multiply top and bottom by the conjugate of what's in the bottom. Okay, so let's set it up. So 3 plus 4i is what's in the bottom. What's the conjugate of what's in the bottom?
3 minus 4.
Yep, 3 minus 4i. And 3 minus 4i. So I am multiplying top and bottom by the conjugate of what's in the bottom. Any questions why I set it up that way? Okay. Now, we have to multiply it out. The top, that's pretty easy. We're just going to distribute the 1. Is that going to change anything? What do you think, Matt? No. When you distribute the 1, it just stays the same. If it was a number different than 1, it would change it. Right? So that's just 3 minus 4i. Now in the bottom, Normally we would have to FOIL it out, but they're conjugates. 3 plus 4i, 3 minus 4i. So I'm just going to use the shortcut. What's the real number? 3. And if we square it? 9. What's the imaginary number? 4. And if we square it? That's it. Bottom's done. Just add up 9 and 16. So 3 minus 4i over 25. Now, as far as the calculations, we're done. But that's not standard form. Standard form has a real part and an imaginary part separate. So this is how you would write your final answer. Real part minus imaginary part. All I did there was take each number and write them separately over 25. 3 gets written over the 25, and the negative 4 gets written over the 25. And I just put the I in front. You can leave the I in the numerator, but most of the time people put the I in front. So now I would say the real part is 3/25. The imaginary part, negative 4/25. Okay, so you don't stop here. You want to go that next step and write it like this. Okay, any questions on that one? All right, let's do one more divide, and then I'm going to start to show you the connection between polar and complex numbers. All right. This one, a little more complicated. So now we've got a complex number in the top and the bottom. So we're not just doing a simple distributive property in the top this time. Okay, we're going to actually have to FOIL it out. Okay, but before I FOIL it out, I got to know what I'm going to be FOILing. So what is going to go in the parentheses in the top and the bottom?
Five plus 12i.
Yeah, why not 1 minus 4i?
Because it has to be the bottom.
It has to be the bottom. Right? The bottom is what we want. The conjugate of the bottom. 5 plus 12i. 5 plus 12i. Now I usually do the bottom first because I think it's faster. If you square the real number, what do you get? 25. What if you square the imaginary? 144. I'll add those together in the next step. Okay, now in the top, there is no shortcut. You just got to FOIL it out. But let's see if we can kind of do some of it as we go. Okay. What's that going to give me when I do that part? 5. Now, let's do this part in our head. 1 times 12i. 12i. 5 times 4i.
20i.
So we had a 12i and we had a 20i. How much is 12i and 20i?
32i.
32i. And now the last part, 4i times 12i. Right? And it's a positive times a positive. What's positive 4 times positive 12?
48.
48. And Jasmine, I times I?
I squared.
So it's 48i squared. What number is that really? 48i squared.
47.
No, 48 times I squared.
Negative 48.
Negative 48. Alright, so 48 times I squared means 48 times negative 1. Alright, so in the bottom, you're going to get 169. When you add those up, in the top, 5 and negative 48 are your like terms. What's 5 minus 48?
Negative 43.
Negative 43 plus 32i. Now, is that standard form? What do you think, Aiden? No, that's not how I would want it written. It's a standard form. Can you tell me, Aiden, what I would be looking for?
Negative 43 over 169 plus 32i over 69.
So negative 43 over 169 plus 32 over 169. And that's the answer. All right, so if you could reduce those fractions, you would. Like if it was like 10 over 20, yeah, make it 1/2. But 43 and 169, that doesn't reduce. Great. So any questions on that? All right. So last thing we're going to look at is we're going to start to see the connection between complex numbers in polar in section 5.3. All right. So when we start to look at the connection, one thing we have to understand is this. This is called the complex plane. It's not an x and a y axis. It's a real axis and an imaginary axis. So the real axis is horizontal. That's taking the place of x. And the imaginary axis is vertical. That's taking the place of y. And what I want to do is I want to just practice graphing complex numbers on the complex plane. If you can graph the point 2, 3, okay, like that, then you can graph 2 plus 3i. It's the same thing. Look at the real part, then look at the imaginary part, and then just graph it. Positive numbers go right, negative numbers go left. Positive numbers go up, and negative numbers go down. It's just like the setup of an XY axis. So, in that one, what's my real part? 2. What's my imaginary part? 3. Real part 2, imaginary part 3. That means I go right 2 on the real axis, up 3, and that's it. That's how you graph the point 2 plus 3i. Any question on that? Okay, let's try this one. Starting from the origin, Jose, could you tell me which way I go to graph that point?
Go to the right first.
Yep, and how many to the right are you going to go?
4.
Yep, we're going to go right 4.
And then you go down 8.
And then we're going to go down because the imaginary axis is vertical, and that's a negative number. So right 4, down 8. 1, 2, 3, 4, 5, 6, 7, 8. There you go. And that's 4 minus 8i. How about negative 8? How would I graph that one? Caitlin?
Just on the R.
Yeah, it's just on the real axis. If you want to think of it as having an imaginary, all right, think of it like that then. Plus 0i. So it's going to be on the real axis. And which way do I go and how many units?
Up to the left.
Just go left 8, which I think is right there. So negative 8. And how about, Jasmine, how would I graph 5i?
You just go up 5.
Up 5. And that's it. That's how you graph it. So any questions on graphing complex numbers? The reason that's important is because when we start to look at the connection, which we're going to do right now, between complex numbers and polar, you have to know what quadrant a point is in. So by me just showing you how to graph it, you should be able to figure out what quadrant your point is in. Okay. So now, the moment you've been waiting for. Right, Ben? This is you. This is what you wanted. This was what you were like hyped about. Yeah, I'm telling you, it's happening right now. It's live. This isn't recorded. This is live. I'm here. Okay. If you're watching this on YouTube, then this is not live, but it is right now for you, but not all of you. All right, so complex numbers in polar. All right, so suppose that we had a complex number. I've done this kind of thing before. Z, I'm just calling the complex number Z. And I know I normally do A plus B. I let the real part be A and the imaginary part be B. Well, I'm using X and Y now because we're kind of thinking about graphing a little bit. And it just makes more sense if I let the real part be X because the real axis is horizontal and let the imaginary part be Y. Now, you might also be looking at this and being like, why did he put I before the Y? It doesn't really matter, right? If you want it in standard form, then yes, technically you're supposed to write this, Y, and the I comes after it. I put the I before it because the formula that I'm about to come up with is going to match what's in your book. Okay. That's called rectangular form. Right? So that's when we write a number, it has a real part and an imaginary part, and that's rectangular form. Just like we studied earlier in the week. That's rectangular. Now, in polar, you don't have an X and a Y. What are the two things you have in polar?
Radius and theta.
Radius and theta, a radius and an angle. And that's exactly what we're going to have to do here, and we're going to use exactly the same formulas we've used all week. So, let's look at how would you write what I just did, x plus iy, how do we write it in polar? So this is the connection. We're taking a complex number that we've been writing a certain way, and now we're going to write it a different way, using the stuff we learned Monday and Tuesday. Now, there's a formula for x and there's a formula for y. Does anybody remember what the formula was for x from Monday? It was something with a trig function and then theta. In fact, it was the only two formulas we did on Monday when we practiced converting polar to rectangular. Yeah,
Was it R? Wait, no. Wait. Yeah, R cosine theta.
yeah, we proved this on Monday. X is r cosine theta. Anybody else remember why?
Just R
Just
sine
R
theta.
sine.
Yep, r sine theta. Okay. So now, I'm going to take this and put it in there. I'm going to take this and I'm going to put it in there. So I'm taking how we used to write a complex number, okay, like this. And I'm changing the x and the y. What am I changing them to? I'm using the polar formulas from Monday. So what we're doing now is we're changing from rectangular to polar. I'm going to show you how to write it. So x becomes r cosine theta plus, the I just hangs out right there. Nothing happens to it. But the y gets replaced with r sine theta. Now, I see something written twice there that if I see something written twice, there's a way to shorten it, so I only have to write it once. If you look before the trig functions, they both have what letter?
R.
They both have an R. So whenever you see the same thing in two different spots, separated with a plus sign, you can factor it out. So we're going to factor it out. If I factor an R out of the first part, what's left?
Cosine theta.
Cosine theta. And if I factor an R out of the second part, what's left?
I sine theta.
Yep, I sine theta. And that is the polar form of a complex number. So that's how you write a complex number in polar. So that's the connection between what we were studying in polar and what we were doing in complex numbers. But I don't really think the connection is that important. I think what's more important is why. Why would you ever write a complex number in polar? We already have a way to write complex numbers. Why are we doing it a different way? Well, remember all the stuff we did when we multiplied and divided? Like when you divided, you had to find the conjugate, you had to FOIL it out, you had to change I squareds to -1s, you had to combine like terms, you had to do all that stuff. Well, if you write complex numbers in polar, you don't have to do any of that stuff. It all goes away. No foiling, no I squareds, none of it. Pretty much makes it so you can do the problem in your head. But we didn't learn it that way first because we didn't know this yet. Now we know this, and tomorrow we're going to learn how do we use this to do multiplication and division a lot faster. There's no faster way to do addition and subtraction. I've already taught you guys the best way I know to do it. You just combine like terms. But multiplication and division, this is way better than what I just taught you, like 20 minutes ago. All right. Okay. So now let's practice a problem. If you're looking at how do you figure out the r and how do you figure out the theta, it's the same way you did yesterday. We used the Pythagorean theorem to find r, x squared plus y squared equals r squared. And to find theta, you guys asked me some questions about that in homework. That's where you use the inverse tangent. So I'm not going to write all the formulas down. You already have them. Inverse tangent y over x. But sometimes you got to do something extra. Does anyone remember? In quadrants 1 and 4, it's always inverse tangent y over x. What are you going to do if it's in 2 or 3? Yep.
180 plus inverse.
Yep, you got to do the 180 plus. All that stuff stays the same. Okay. So when we do this problem out, I'm not saying this is the answer, but I'm going to show you what a final answer looks like. 5 cosine 20 degrees plus I sine 20 degrees. That's a final answer. You don't do anything with it. If you say, well, should I take the cosine of 20 and distribute the 5? No, you stop there. That's a final answer.
Why wouldn't you take the cosine of 20?
Because if you actually take the cosine of 20 and then distribute the 5 to it, you're changing your answer back to what you started with. Okay? Same thing here. If you took the sine of 20 and distributed the 5 to it, you'd be changing it back to what you started with. Okay? So I'll show you, we'll try it here. I'll get to the end, I'll circle the answer, I'll say this is the answer. And then we'll distribute it out and you'll see, oh, we just changed it right back to what we started with. Okay, so don't distribute it out. Okay. So I can set up the template of what my answer is going to look like. I'm going to have an r, I'm going to have a cosine, leave a little room for theta, plus I sine, leave a little room for theta. That's what my answer is going to look like when I'm done. Just find r and find theta. Let's start with r. What's the formula for r again? R squared equals it's from yesterday, about then. What's the formula here for r squared? R squared equals Jose? It was step 3 in the notes yesterday. Not sure. Caitlin?
X squared plus y.
R squared equals x squared plus y squared. Now you don't really need to remember that because that's just what? It's just the Pythagorean theorem. Right? Think about if you graph that point. The square root of 3 is about 1.7. Now, what's the imaginary part here? There's no number in front of I. So what would it be? Be negative 1. Excuse me. So if you were graphing this point, square root of 3 is about 1.7, down 1. So right 1.7, down 1. There's your point. Make a triangle out of it. This side is about 1.7. This side is 1. You're finding the hypotenuse. You're using Pythagorean theorem to figure out this right here. Okay, so let's do it. The real part is the square root of 3, and I'm going to square it. The imaginary part is negative 1, and I'm going to square it. What's the square root of 3 squared? 3. Square and square root cancel out. What's negative 1 squared? 1. 3 plus 1 gives me 4. Remember, this is r squared. So what's r? 2. That's the radius in the final answer. So my radius is 2. Okay, last thing I need to find is my angle. Now, to find the angle, depends on what quadrant you're in. I've already graphed the point. Okay, and this is what we learned very first thing in this section. How do you graph complex numbers on the complex plane? So what quadrant is that point in?
4.
Yep, quadrant 4. What's the formula to find the angle if you're in the 4th quadrant?
Inverse tangent divided by y over x.
Can you say that again? Inverse tangent?
Times y over x.
No, there's no multiplication to find the angle here.
Would it just be the tangent of y over x?
Of, yes. You have to plug in a number into the inverse tangent. Think of the inverse tangent as like, it's like a box. You got to put something in it. You're not multiplying it by something. You're putting something inside it. Okay, what are you putting inside it? Y over x. What's y in my case?
-1.
Yep, it's just numbers. -1. And what's x? Square root of 3. So let's see what we got. Inverse tangent of -1 over the square root of 3. I'm already in degrees. This problem didn't say how to do it, but I prefer degrees, so let's do it that way. -1 divided by square root of 3. Oops. We get an angle of -30. -30, -30. And that is a perfectly acceptable answer. Now, what can you always add if you wanted to make a negative angle positive? Yes. If you add 360 to that angle, what do you get? 330. So this is also a perfectly acceptable answer. 330 plus I sine 330. Okay, which one is more right? Neither one. They're both right. It's just one time you did it with a positive angle, one time you did it with a negative angle. And we've talked about this in polar. There's many ways to write the same answer. Now, that's where you stop. If you took the cosine of 330 and multiplied the 2 out, what would you be doing? Because I said stop here. If you don't, you're going to be doing what?
Same as what you started.
You're going to be changing it back to what you started with. So if you take, don't do this, just watch it. If you take the cosine of 330 and then distribute the 2 to it, you get the number 1.73. Take the square root of 3 and see what that is. You just changed it back to what you started with. What would you get if you took the sine of 330 and multiplied it by 2? You would get -1, as long as you did the problem right. You would be changing it back to what you started with. Okay, so we don't, oops, I just forgot a parenthesis. We don't want to change it back to what we started with. Okay, so any question on that? Okay, so finding r and theta, just like what you did on Tuesday. Okay. Okay, so the homework, first part is on the multiplying and dividing complex numbers. Page 560, 15 to 27 odd, 28. And page 333, that's what we just did, graphing complex numbers and writing them in polar. Okay, so tomorrow you'll actually see, okay, we know what the connection is now between what we were studying in polar and what we did in complex numbers. how fast does it make multiplication and division? Very fast. And I'll show you that tomorrow.